Welcome to Math Antics. In this lesson, we're going to learn about ratios. Well, what in the world's a ratio? Well, let's look it up in a math book to find out. It says here that a ratio is a comparison of two numbers by division. Well, that's true, but it's also a little confusing. And it's confusing because most of us think of comparing numbers as trying to decide if a number is greater than, less than, or equal to another number. But with ratios, we're not trying to compare numbers like that. Instead, we're really trying to see how two numbers relate to each other. And so at Math Antics, we like to think of ratios as a relationship between two numbers by division. Okay, but how do you compare or show how two numbers are related by division? Well, to see what the by division part really means, let's look at an example of a ratio. Excuse me, that's not a ratio, that's a fraction. Oh, it's a ratio all right. Mathematically, ratios and fractions are basically the same thing. It's just that when we use a fraction in a particular way, we call it a ratio. Well, sure, everybody knows that. Well, like I was saying, ratios are basically just like fractions. The difference is how we use them to describe things in the real world. To see what I mean, let's look at examples of how we could use the fraction 1 over 2 and the ratio 1 over 2. Mathematically, these are both the same thing. They're just the division problem 1 divided by 2. But in the case of the fraction, we usually treat it as if it's just a single number. For example, at lunchtime, you might eat 1 sandwich, or if you're really hungry, you might eat 2 sandwiches. But if you're not very hungry, you might just have half a sandwich. We can use the fraction 1/2, just like we use 1 or 2 to show how many sandwiches you eat. It's just that in the case of 1/2, we know that it's only part of a sandwich, just a fraction of one. Now let's see how we can use the ratio 1 over 2. With a ratio, we don't treat it as if it's just a single number. Instead, we pay close attention to the top and bottom numbers because we use them to refer to different things. For example, let's say we're planning to go on a picnic. And for every 2 people that are going on the picnic, we're only bringing 1 sandwich. In that case, we'd say that the ratio of sandwiches to people is 1 to 2, or 1 sandwich per 2 people. Do you see the difference between our fraction and our ratio? The math part of each of them is the same. But with the fraction, both the top and bottom numbers are referring to the same thing, the sandwich. However, with the ratio, the top and bottom numbers are referring to different things, sandwiches and people. The fraction shows a part of something, but the ratio shows a relationship or a comparison between 2 different things. And you can see that they're the same thing mathematically, because if you did have the ratio of 1 sandwich per every 2 people on a picnic, guess how much of a sandwich each person would get? Yep, half a sandwich. All right, so now you know that fractions and ratios are basically the same thing. But since they're used differently in math, sometimes they're also shown differently. Once in a while, instead of seeing the standard division form, a ratio might be represented with this symbol. When you see a ratio written this way, it just means 1 to 2 or 1 per 2. For example, in this picture, you could say that the ratio of dogs to cats is 3 to 2. 3 dogs to 2 cats. And you could also write it in the standard division form, 3 dogs over 2 cats. They're just different ways to write the same ratio. Ratios are used all the time to represent all sorts of things in real-world situations. So let's see a few more examples to help you really understand what ratios are. Have you ever wanted to compare apples to oranges, but someone told you couldn't? Well, you can with a ratio. Now let's say a fruit stand sells 5 apples for every 3 oranges they sell. The ratio of apples to oranges would be 5 to 3. Or, have you ever helped someone bake cookies? The recipe might tell you that for every 2 cups of flour, you need 1 cup of sugar. That means that the ratio of flour to sugar is 2 to 1. Or, what about your TV screen or your computer monitor? Have you ever heard someone say that the size or aspect ratio is 16 to 9? 16 to 9 is the ratio of the screen's width to its height. So if the screen is 16 inches wide then its height would be 9 inches tall. Ah, here's another good ratio that you might use in your car. 40 miles per hour. Aha! Didn't you say that a ratio was a relationship between two numbers? But 40 miles per hour is just one number. Looks like someone's got some explaining to do. Actually, there are two numbers. Do you remember how any number can be written like a fraction just by writing 1 as the bottom number? Well, 40 miles per hour is the ratio 40 miles per 1 hour. Well, I guess you have an answer for everything, don't you? 40 miles per 1 hour is a type of ratio that we call a rate. A rate is just a ratio that usually involves a period of time. Here are some common examples of rates. 10 meters per second, $12 per hour, 3 meals per day, 50 games per year. Notice that the bottom numbers in each of these ratios relate to a period of time. Seconds, hours, days, years. And that's why we call them a rate. Alright, so that's simple enough. But you might be wondering, why are the bottom numbers of all these rates 1? Couldn't you have a rate like 90 meters per 9 seconds? Or $60 per 5 hours? We sure could. But most of the time, when we have rates like that, we want to convert them into an equivalent rate that has 1 as the bottom number. And that's because whenever the bottom number represents only one unit of time, like 1 hour or 1 day, it makes comparing different rates much easier. For example, imagine two cars driving at two different rates. The first car's rate is 120 miles per 3 hours, and the second car's rate is 150 miles per 5 hours. Which car is going faster? Well, it's not all that easy to tell when the rates have different bottom numbers. Fortunately, it's really easy to change a rate so that it has 1 as the bottom number. All you have to do is divide the top number by the bottom number. The answer you get is the top number of the new equivalent rate, and the bottom number is just 1. Rates like this are called unit rates because unit means 1. All right, let's convert the rates of speed for our two cars into unit rates so that we can compare them easily. The first car's rate was 120 miles per 3 hours. So if we take 120 and divide it by 3, we get 40. That means that the unit rate for the first car is 40 miles per hour. The second car's rate was 150 miles per 5 hours. So if we divide 150 by 5, we get 30. So the unit rate for the second car is 30 miles per hour. And now you can easily tell that the first car is going faster. And you can tell why unit rates are so helpful. Okay, so that's it for this lesson. We've learned that a ratio is basically just like a fraction. But instead of showing what part of something you have, it shows the relationship between two different things. We also learned that when one of those two things is time, we call the ratio a rate. And last of all, we learned how to convert a rate into a unit rate for easy comparison. As always, thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.